So welcome everybody to my talk. I am Matt Graber of NASA JPL, and I'm going to be talking today about how NASA, GIBS, and Worldview have been enabling open exploration of our world. So first I'm going to get into some background. So how many of you are familiar or have used GIBS or Worldview? Oh, okay, that's a good amount. Yeah, so for those of you who aren't familiar, Worldview is an interactive web-based tool for browsing, comparing, animating, and downloading over 1,200 different satellite data products. And GIBS is kind of the backbone of Worldview. It's an API that enables fast and open access to visualized data of Worldview via standard web services such as WMTS and WMS. And yeah, so now we'll take a step back in time and look at how we got here. So there's kind of two parallel timelines going on here at JPL and at Goddard Space Flight Center. So first at JPL, there was a lot of mapping exploration going on. So in 1998, the first full resolution mosaic of the United States was produced using Landsat imagery, and at the time that was the world's largest image. And then they went up that in 2004 with the first full resolution global Landsat mosaic. Which very much not full resolution version you can see there. And while this was going on at Goddard Space Flight Center, in 2001 a capability was developed for producing near real-time imagery products from MODIS imagery. MODIS is a multispectral imager on board two different Earth orbiting satellites, Aqua and Terra. And that near real-time capability was produced and intended for the agencies like the Forest Service to monitor fires, but other people found plenty of other good uses for it with climate science and outreach. So based on the success of that, NASA has established LANCE, which produces near real-time products for a much wider variety of missions. So both of these timelines kind of converge in 2011 with the creation of GIBS and Worldview. So basically, Goddard's near real-time product generation was combined with JPL's mapping technology, and that led to GIBS and Worldview. And initially at launch, we had about 10 visualized products, and now we're at over 1,200 from NASA and partners like USGS and NOAA and international partners. And we've got 100,000 daily users usually, and we have tens of millions of requests served per day. To date, we've had hundreds of billions of image requests served in total. We're rapidly approaching trillions. And initially, when we launched, we were an on-premises system. The last couple of years, we've been a hybrid system, and we fully finished transitioning to the cloud this past February. So next, I'm going to talk a little bit about Worldview. So Worldview is kind of like the user interface of GIBS, and it's got historical and near real-time image browsing. It's got great tools for making animations and comparing things like you see there. And I'm actually going to play this video demo. So you can see we've got what we like to call tour stories in Worldview that lets users, it gives users a tour of some of the visualized products and tools we have available in Worldview. So this one's showing fire locations across the United States and kind of explaining what you're looking at. We've also got up in the corner there, you can see this, where it says events, that's our natural events browser. And that lets you zoom quickly to a particular natural event that's going on, like a storm, for example, or a volcano. And one of the other really great things we can do is see comparisons. So for this example, after this hurricane hit Houston, we can set up a comparison with the nighttime imagery to see how the electricity was knocked out for much of the city and how dim the lights got. We have a tool for exporting imagery, and you can very easily import that into Google Earth and view it in that context as well. Yeah, pretty soon we'll also have a basic tool for creating time series with our data. And one other thing that Worldview has, where's my mouse? Oh, my mouse is gone, but I guess, oh, it's over there. One other tool that Worldview has available is in that data tab we see up there. You can very easily be linked to Earth Data Search, where you can download the actual imagery granules for whatever imagery you are seeing to do your own analysis with the full precision data. Oh gosh. All right. So GIBS is the backbone of Worldview, and it's been used by, obviously, Worldview and over 1,000 other applications as well. And it serves imagery via WMTS, WMS, and TWMS protocols, and it's obviously compatible with QGIS and ArcGIS. There's an example of a WMS request served through GIBS showing paste chlorophyll ocean data overlaid on VIIRS imagery. VIIRS is another Earth orbiting instrument, hyperspectral instrument like MODIS. Yeah, so now I'm going to take a step back and talk about what else is going on with Earth science and openness at NASA. So one of the big pushes at NASA right now is the TOPS program, which stands for Transform to Open Science. And the goal is to transition basically everybody that they can to a culture of open science. So that includes like open data and open source software. And there's a free training curriculum you can do on their website, either self-paced by yourself or with a instructor virtually, or even in person, depending on where you live. And after you complete that training program, you can actually get this fun badge that goes on your LinkedIn profile. So I'd encourage anybody to sign up for that if you have time. Yeah, so Earth science data at NASA has been free and open to everyone since 1994. And all of the system software developed through NASA R&T awards have been open source since 2015. GIBS and Worldview have been open source since 1 year earlier, 2014. And both of these applications, obviously they enable free and open browsing of Earth science data, but they're also open source on GitHub, so people can take them and use them for whatever other applications they have in mind. So within NASA Earth, GIBS falls under ESDIS, which is the Earth Science Data and Information System group. And there's a couple other projects I wanted to highlight kind of in that realm. One of them is Earth Data GIS, or EGIS. And this is more of a general purpose GIS provider for quote unquote traditional GIS. So this would less web browsing and more of putting the data into ArcGIS or QGIS for analysis. And we're still working on defining what our role in GIBS versus EGIS's role is in NASA's Earth data ecosystem. There's also NASA OpenScapes, which is an initiative to support researchers as NASA's Earth data projects transition to the cloud. And they provide a cookbook with a bunch of recipes for how to easily do operations with Earth data. And they also have a Python library to make that easier as well. So next I'll give a quick overview of some of our users. So here's a glance at some of our metrics recently. So for most of the month of August and some of July, we had over 2.5 million unique IP addresses requesting our tiles. And in that plot on the left there, you can see our most popular layers, mostly the VIIRS and MODIS imagery, like that true color imagery that you first see when you open Worldview. It's getting several million requests per day. And then on the right, you can see some of our performance metrics. So we usually try to keep our request serving times to tens or hundreds of milliseconds. Yeah, so since we've become very popular for scientific usage as well. You can see the plot as we've grown and how our citations have grown as well. And researchers have used us for things such as monitoring glaciers as they disintegrate or melt or whatever, and also hunting for elusive phenomena such as Milky Sea. So these are things that happen when it's thought to be bioluminescent bacteria that suddenly all bloom at once at night. It's very rare, very few people have seen that in person, but people are able to track them down on Worldview in our nighttime imagery. We're also a part of NASA's Earth Information Center, which is active at NASA headquarters in DC and also online at earth.gov. And pretty soon it'll be in the Smithsonian as well and at Kennedy Space Center. Highly encourage any of you to visit that when you're in DC next. But it's kind of like a mission control for Earth. So we contribute those Worldview visualizations in the middle of that panel there. We also contribute to Eyes on the Earth, which is a part of that. So this is a very fun application where you can see the real-time views of NASA's Earth science fleet as they orbit the Earth, and we contribute that Earth imagery that is put on that sphere underneath them. We've been used by journalists plenty of times in news reports, often for fires or storms or glaciers melting. We've been shared on social media a bunch for a variety of reasons, often for storms. There's somebody in the corner there showing that comparison of Houston I showed earlier, and we've been shared for showing how easy it is to access healthcare in certain regions of the world with different weather conditions, and we've been shared by the former International Space Station commander and Canadian astronaut Chris Hadfield as well recently. We've been used in a whole lot of websites. Some highlights here. We've been using like weather websites such as Zoom.Earth, fire tracking websites like NASA's FIRMS, airplane tracking websites like airplanes.live, ocean tracking like NOAA's Ocean View, and also we've been used by a company called Reflect Orbital on their website, and Reflect Orbital is a company that is trying to sell reflected sunlight to the night side of Earth. They have a visualization tool on their website using our imagery. We've been used in planetarium shows as well at the Hayden Planetarium and California Academy of Sciences in San Francisco, and our imagery is also integrated into the Open Space Project, which is a free and open source NASA-sponsored planetarium project. And then one of my favorite use cases recently has been this individual who has been sailing the Northwest Passage north of Canada in the Arctic Circle. They have a satellite internet on their sailboat, and they've been using Worldview to track the location of ice flows to avoid. So next I'll get into our architecture real quick. So we're kind of built around the meta-raster format, or MRF. And this was originally developed in JPL in the 2000s, and it's a tiled pyramid imagery format. And it's similar to COG in many ways, but for our use cases, it has faster write speeds and other capabilities, such as the ability to add imagery to an existing MRF without having to regenerate the whole thing. So that's very important for near real-time imagery. It's also built into the GDAL and can handle any GDAL compatible format, and is supported by common GIS software like ArcGIS and QGIS. So if GIBS is the backbone of Worldview, then OnEarth is the backbone of GIBS. So OnEarth is the free and open source high performance tile server that basically supports GIBS. It is GIBS kind of. And it provides WMTS and TWMS services and WMS via map server, which is built in to it. And it also has tools for generating MRF files and handling time periods as you're ingesting data. This has been around in some form or another since the early 2000s, and today we have a microservice architecture with it. So let's say you have a need for serving more WMTS requests but fewer WMS, you can scale up the WMTS service more than the WMS. And why did we develop this solution in the first place? Well, we needed time-based imagery access, especially for WMTS, and at the time this was created, we didn't really have any other option for that. It's supported our use cases very well for the last 20 years or so. And it also has very lightweight and fast tile reproduction, which saves us about half our storage costs that we would otherwise have to store those reproduction tiles with. Yeah, so up until this past February, we've been running OnEarth v1 in the cloud. Last couple of years, we've been doing both v1 and v2, or not in the cloud, that was on premises. We've been doing both v1 and v2 last couple of years, and now we're fully transitioned to v2. Both of these are open source on GitHub, but OnEarth v1 is no longer supported. So OnEarth it consists of those 5 Docker images which make up those microservices. So the first one is the tile services. So this is what handles those WMTS and TWMS requests. And this is built on OTSI, which is the Apache HTTPD tile server ecosystem developed by somebody who was previously at JPL and is now at Esri. And this can serve JPEGs, PNGs, LURCs, TIFFs, and can also decode imagery on the fly from formats like Brunsley JPEG, which is a JPEG compression format, and ZenJPEG, which is sort of JPEG with transparency, so that lets us store JPEGs for those layers that need that transparency instead of PNGs. We've also got the reproject image, which handles the reprojection to Web Mercator. That's using a Apache module called modretile, which is a part of OTC. We've got the time service, and this handles querying Redis, which is what we use for our time periods database, and also handles snapping time requests so that users don't have to request the exact precise imagery time if they don't know it, but we'll give them the thing that they probably wanted. We've also got the capabilities image, which generates those get capabilities documents for each protocol. And the WMS image is what includes map server to do those WMS requests. And these WMS requests are served by map server querying our own WMTS service to assemble those maps. Here's a brief overview of our request serving architecture. I won't spend much time on this, but this diagram in the corner here is available on the GitHub page for OnEarth if you are interested in looking at it more. So for our ingest pipeline, we use the utilities available in OnEarth to generate those MRFs and put them in S3 buckets in AWS. So we use the mrfgen.py tool to do that, and we put the MRFs in the S3 bucket and the MRF index files in EFS for faster access times. And we also have time utilities from OnEarth that we use to regenerate those time periods that are needed for serving the imagery, and we put that in Redis as we ingest that data. So like we said, we are fully open source with OnEarth and Worldview, so other people have set up their own instances. Other groups at NASA have done this, as well as at NOAA and at some universities as well. So next I'm going to give a brief overview of our future directions. So one thing we are really trying to investigate for future use is dynamic data to image visualization. So I don't know if any of you were at yesterday's T-Tyler talk given by DevSeed, but we have been investigating that heavily. And we actually do have a demo right now live in Worldview showing selectable bands with using this dynamic data to image capability that T-Tyler offers. And this is connected to NASA Impact's Veda T-Tyler implementation, which was talked about yesterday. So yeah, and we are also looking to eventually get 3D visualizations capability to serve those. So this could be like data curtains or point clouds or altimetry. And we actually, a couple years ago, we did make a demo with Cesium showing how that could look. And we did another one with Unity showing how this could be used in the AR or VR setting as well. We're also looking to implement support for the OGC APIs in the near future too. And if there are any other standards that any of you would like us to support, please feel free to raise your hand after the talk or get in contact with us. Like I said earlier, Worldview currently supports animations, but wouldn't it be great if GIBS could do that too? Because Worldview currently does this on the client side by requesting individual GIBS tiles and then putting them together into GIFs. But GIBS could generate and serve the animations via the API response entirely on the server side. So that's something we're looking into by having the tiles streamed to the user. Finally, we've been investigating some AI and ML integrations with Worldview. So first, I did mention earlier that we have a natural events browser in Worldview. So this shows the live locations of natural events that are occurring. But on a particular day, it might be cloudy in some locations. So a natural event like a volcano erupting could be completely obscured by an unrelated hurricane or something happening right above it. So using a vision language model, you could have the natural advanced browser filtered for only the events that are actually visible at a particular time. So that's one use case. We have prototyped that, and here are results. It's looking pretty promising. And then another thing we've been investigating is a sort of worldview navigation assistant. So this is kind of like a large language model type of application where you are able to tell the LLM, hey, show me a large Canadian wildfire of 2023 with the associated thermal layer, and then it'll give you back a worldview URL showing exactly pretty much what you asked for. So that's what you see there. And another one, it can even get more complicated, like show me the changes between 2 dates for the Earth's methane concentrations, and it'll generate an animation in Worldview for that. So yeah, so we're looking to eventually maybe integrate that into Worldview as a capability. But yeah, that's all I have for now, and I'm open to questions. Thanks. Yeah.
Thank you for your talk. GIBS really is like a key service. You had mentioned challenge, but generating like log recipes now variables prop anything to that. These go.
Yeah. So the question was about the challenge related to generating reduced resolution overlays for the dynamically produced data, like from T-Tyler. So the issue with this is that when we use this T-Tyler demo in Worldview, it's only enabled for the really zoomed in layers right now. And when you zoom out, in order to generate that reduced resolution data, you have to have knowledge of all of the data beneath that. So it's a much wider area of data that you have to reduce on the fly, and currently we don't have a good solution for doing that quickly. As compared to like just the small area that you're looking at, there's the actual data underlying that is basically what you see in that frame. But if you were to zoom out, you have all of that data and all of the data in the surrounding frames that you have to somehow coalesce very quickly into a reduced resolution. So you're basically asking it to generate that imagery for that whole area that is encompassed by that zoomed out layer.
Is there a pipeline for your adjusting that and take a part on your request?
So the On-Earth provides the tools that are used by the pipeline. The pipeline itself is actually not open source because it's really just infrastructure code. Nothing super interesting there. But yeah, we do provide everything you need to build your own with this, which is basically mrfgen.py and a script for creating those time periods based on the data that you're ingesting.
How free are you? Is there the break when someone didn't have and then use it or service? Is there like a point or like what point at which you would want them to launch?
Yeah, no, we don't have any restrictions actually. You don't need any login or any API keys or anything. You can just hit us with as many requests as you want, pretty much.
So you mentioned leading I guess metadata living it time where that can be very good.
The metadata for the image files? So my understanding is that comes from NASA's Common Metadata Repository. So that's, Worldview gets that metadata from that CMR repository. GIBS itself isn't fully linked to that, but in Worldview, you can do that. And I think you can do your own requests to CMR for that metadata.
Yeah, so it's just a vessel.
Yeah.
That any task your own bot.
I don't think you can at this point, yeah, unfortunately. So if nobody has any other questions, I guess I can real quick show if the internet works. A very quick demo. Oh, geez. That being said, the internet might not work. But
Set up the next talk.
okay, yeah. So yeah, I guess I'll end it there. Thank you.